And this chapter is all on nutrition. So we've already talked about our macromolecules like carbs, lipids, and proteins. We're just going to talk about them a little bit more in terms of how much of each of these your body needs and what you're using them for. We'll also talk a little bit about vitamins and minerals. So to talk about nutrition, there's a couple terms we need to define, like nutrient. Nutrient is just anything that you take in, any substance, in food that's used for growth, maintenance, or repair. So you're taking it in and it's helping to produce energy, it's helping you grow, it's helping you just maintain your homeostasis, or it's helping to repair. The major nutrients that we consume are macronutrients. Macro means big, so you actually need these in large amounts. So this is the bulk of the ingested food that you're consuming. So carbohydrates, lipids, proteins, nucleic acids, and water. Okay. We're only going to focus on the ones that I have listed up here. We're not going to talk much about nucleic acids. Other nutrients, because we don't need them in as much of an amount, are considered micronutrients. Right? We know micro means small. So these are our vitamins and our minerals. So we're going to do our macronutrients first, carbs, lipids, proteins. We'll also touch on water. So why do we need carbs? Carbs are our major energy source, right? When we think back to cell respiration, and I'd write that on the board. I make this really easy so that y'all can remember it. This is not the actual equation. It's not carbs, it's actually C6H12O6, which is glucose. But glucose is a sugar. It's essentially a carb. So where do we get carbohydrates from? It's mostly from plants. It's where carbs come from. Now, starch is a complex carbohydrate. We find this mostly in grains. We also find it in starchy vegetables. What are starchy vegetables? Rice? Potato. That's kind of a grain. Potato? Corn? Right? These are starchy vegetables. Starch tastes like starch, right? It tastes like bread. It has a very distinct taste to it. But we also have other carbs like sugars. Sugars are considered carbohydrates. Sugars like monosaccharides and disaccharides. And these can be found in fruits, sugar cane, sugar beets, honey, milk. All of those have sugar in them. And sugar tastes sweet. So monosaccharides and disaccharides have more of a sweet taste, whereas polysaccharides, starches, they taste like a starch, right? They're not quite as sweet. Two other places where we find carbs that you might not think about as a carbohydrate is fiber. Fiber is a carb, right? We have two kinds of fiber. Insoluble fiber. This is a fiber that we find in vegetables, usually like cellulose. Insoluble fiber is just what it sounds like it is. It's insoluble. You can't break it down. It does not get absorbed, does not dissolve in water. Instead, it's going to pass through the small intestine and then through the large intestine. So the main function of insoluble fiber is it bulks up the stool. Okay? So it basically increases your roughage, increases the bulk of the stool. So examples of where you can find insoluble fiber would be like green beans, celery, brown rice. These have a lot of insoluble fiber in them. This is good for a lot of reasons. One thing is that because it bulks up the stool, it keeps you having more regular bowel movements, which is good to prevent things like colon cancer and cancer in the rectum. But also, these are things that are going to help you feel full longer. When you eat food that has a lot of insoluble fiber, like the difference between brown rice and white rice, brown white rice has all of the germ and the bran left on it. That's that insoluble fiber, so when you eat it, you feel full. And you're going to feel full longer because there's roughage in there. White rice has had all that stuff removed, and it's basically just sugar. So you consume it, and your body gets rid of it really fast. Your blood sugar spikes, and then it comes right back down. You don't feel full as long with stuff like that. Soluble fiber, this is the stuff that can dissolve, it gets pulled into your bloodstream, and this one is important because it can reduce your blood cholesterol levels. It soaks up cholesterol. So my dad, when he had a heart attack last year, once he was okay and he was home and he was recovering, I sent him 15 boxes of Cheerios because my dad had a really bad diet. And I was like, you have got to get your diet under control. Here are some Cheerios. You eat Cheerios every morning. And you know on the Cheerios box, there's a big heart. It says this is heart healthy. The reason is because it's oats. And oats are soluble fiber, and they can cut your cholesterol down, which is important, right? So things like apples, bananas, and carrots, and oats, all these have soluble fiber in them. So carbohydrates, these are used basically as the main energy source for our body. This is what we use to make energy. And it's really glucose, right? I told you that I always just write carbs up here to make it easy. But really it's C6H12O6, which is glucose. So glucose is used by your cells to make energy. But some cells can use fats for energy. But cells like neurons and red blood cells, they have to have glucose. They cannot use anything else. So neurons, if they don't have glucose, they will die very quickly. So you have to have sugar going to your neurons. If you have too much sugar, too much glucose, it'll get converted to glycogen or fat, and it gets stored. Okay? Glycogen can get stored in the liver. So the reason we would do this would be if there's ever a time like in the morning you haven't eaten yet, your blood sugar is probably pretty low. Your neurons need sugar. So what's going to happen is your liver is going to take that stored sugar, that glycogen, and release it in your bloodstream to bring your sugar levels back up. So you can function, you can mentally think things through, right? Your neurons have some sugar. But if you're always consuming extra sugar and your liver has got enough glycogen stored, you're going to start storing it as fat. And fat is usually where we store it is going to be in the hypodermis. We call that subcutaneous fat. Fructose and galactose, so other kinds of sugar will get converted to glucose by the liver because that's what your cells use to make energy. They use glucose. So this is just showing you if you take in food and drink and they have glucose in them, it goes into your bloodstream. And from there, your cells can use it to make energy. So you can see it's going to your body cells, you're making energy. Or your muscles can use it, and that can help them contract. Or you can store it in your liver as glycogen. So you can bring your sugar up later if your sugar ever drops. What causes your blood sugar to get low? Does anybody know? When does your sugar get low? Just when you haven't eaten, right? If you haven't eaten anything, your blood sugar is going to be a little low. You ever feel like when you're really hungry and you haven't eaten anything, you feel a little lightheaded, you might feel a little dizzy? It's because your blood sugar is low. Because sometimes it makes you feel nauseous. So the dietary requirement for carbohydrates is somewhere between 45 and 65% of your total caloric intake for the day. So that's huge, right? I just told you about how grains are sort of the base of the food pyramid. And grains are mostly going to be those carbohydrates. Mostly, though, what we say when we say 45 to 65%, we're talking about complex carbs. So we're talking about whole grains. We're talking about vegetables that have complex carbs in them. If you're not consuming carbs, if you're doing a low carb diet like a keto diet or you're doing a no carb diet, then you're going to use fat and protein as your major source for energy. So again, this is why people lose weight really quick. But they usually, once they lose weight and they start eating carbs again, it comes right back on. Okay. The American diet is usually spot on. We're at about 46% of our daily caloric intake being carbohydrates. The problem is we mostly consume the wrong carbohydrates. So most of what we consume is going to be inexpensive food like rice, pasta, things that are highly refined. So white bread, Wonder Bread, rice, pasta, anything that's white, that's basically just sugar. It has no nutritional value to it, and this can lead to obesity. And the reason for that, when you refine a carbohydrate, so if you take brown rice and you wash it and you get all of the germ and the bran removed from it, you're left with white rice. You've just taken all the good stuff off, right? You've taken off all that fiber. So now you're left with white rice, which is nothing but sugar. It's just a carbohydrate. And so what happens is you consume, let's say, some white rice, your blood sugar spikes. It goes way up. because that's all white rice is just sugar, right? Or Wonder Bread, it's just sugar. Your body rushes to remove the extra sugar, so then your blood sugar goes from way up here to way down here. Blood sugar tanks, you feel tired, and guess what else? Hungry, you feel hungry again, so then you eat some more. And usually you're going to eat more refined carbs because they fill you up real fast. Sugar spikes, then it tanks, and then you do the same thing over and over again. So this is why people, when they're eating a lot of refined carbohydrates, not only are they hungry all the time, but this can also lead to obesity. Like, I'm not a big breakfast eater. And like pancakes, I love pancakes, but I don't like to eat them because I don't like the way they make me feel. Like if I eat pancakes, I'll feel so full after I eat them. And then like an hour later, I'm starving. And that's just because you've just eaten nothing but sugar. Now we also have lipids. Those are another main macromolecule. Lipids are also a source of energy, but they also are a source in our body, and they play a big structural role. So there's two kinds of lipids, triglycerides and cholesterol. That is a lipid. So triglyceride, tri means 3. So triglycerides are basically 3 fatty acids with a glycerol backbone. So they're bound to a glycerol molecule, right? And that's something that y'all should have learned in 103. Now, triglycerides can either be saturated or unsaturated. Saturated fats, these are the fats that we find in meat, right? Like red meat has a lot of saturated fat in it. This is typically coming from animal products, right? So saturated fats might come from meat. They also come from dairy food, like milk and cheese has a lot of saturated fat in it. And there's some tropical oils that have saturated fat in them. And definitely hydrogenated oils or trans fats. Unsaturated fats are mostly coming from vegetables. They're mostly coming from seeds and nuts. So olive oil, vegetable oil, sesame oil, those are all considered unsaturated fats, right? So let's look at this picture because I want to talk about the difference between an unsaturated versus a saturated fat. Which one of those is better for you? Does anybody know? Unsaturated is better for you. Yeah. So unsaturated is an oil. So it's going to be a liquid at room temperature. So like olive oil, vegetable oil. You probably heard people say it's better to cook with oil than butter. Butter is a saturated fat. It's a solid at room temperature. Okay. So we'll say liquid at room temp. Are unsaturated fats, and saturated fats are solid at room temp. So think like butter, lard, cheese.
Crisco.
Lard, yeah. So if we look at this picture, each one of these is a triglyceride. So these yellow molecules here, these are our fatty acids. So you can see there's 3 fatty acids, and they're bound to a glycerol backbone. Triglyceride, 3 fatty acids, and a glycerol backbone. So I'll write that on here. So 1, 2, 3, and here's my glycerol backbone. So these are considered saturated fats over here. So the reason this is a saturated fat is because these fatty acids, notice how these fatty acid molecules are really straight for the most part. They are straight because they are saturated with hydrogen ions. So there's nowhere in this bond here where you don't have a hydrogen ion bound to it. So it gives the molecule a very straight structure. So these are all saturated fats. And because these fatty acids are really straight, if you think about it, we can squeeze them together really tight. We can make something that's a solid at room temperature. Think butter, think lard. Okay? These over here are unsaturated fats. So an unsaturated fat still has the same thing, has 3 fatty acids and a glycerol backbone, right? That's our triglyceride. But these fatty acids are unsaturated with hydrogens, meaning there are places on this fatty acid where you do not have a hydrogen molecule bound, and in place of a hydrogen, you have a double bond. And if you've ever taken chemistry before, you know that when you add a double bond in a molecule, it causes it to kink. So it gets like a bend in it. So that's why you can see these fatty acids are not stick straight. They have all these bends and kinks. Now, if you look at these molecules, because of the bend, you can't put them together quite as tightly as you can over here. That's why these are a liquid at room temperature, right? They're a little more flowy because you can't put them together quite as tight, okay? So that's chemically the difference between a saturated fat versus an unsaturated fat, okay? So again, unsaturated fats are better for us than those saturated fats. The other thing that is a lipid is cholesterol. Cholesterol is a structural molecule. We use it in our body in the plasma membrane of all of our cells. Plasma membrane is a phospholipid bilayer, and it's very liquid. And so we add cholesterol to it to make it more stiff. Problem is, the more cholesterol you have, the stiffer it gets. So this is why people who have really high cholesterol get things like atherosclerosis, right? The arteries start to get real stiff, and it causes your blood pressure to go up. And that's not a good thing. We don't want that. Where we find cholesterol is in places like egg yolks, meats, organ meats, like people who eat liver, shellfish, milk products, they all have cholesterol in them. And you really don't need a lot of cholesterol in your diet because your liver makes about 85% of the cholesterol you need in a day. So honestly, like usually they say like 2 egg yolks is all you need all day in terms of the amount of cholesterol. So usually we end up getting a lot more cholesterol than we need. So I want to mention a little bit more about these fats. So I told you that our saturated fats are not quite as healthy, right? We can stick them together real close to make a solid at room temperature. Unsaturated fats are better for you, right? They're missing hydrogens. They are unsaturated with hydrogens. So what scientists thought probably like, I guess it's been about 40 years ago, maybe more, they said, if an unsaturated fat is better for you, like olive oil, let's take olive oil and saturate it with hydrogens. And if we add hydrogens to it, then we can get rid of these double bonds and make it look like this, and we can make it look like a solid at room temperature. But we started with olive oil, so that's going to be better for you. That's called hydrogenated vegetable oil. So if you've ever heard of that term, hydrogenated vegetable oil, we also call it a trans fat. That's what that is. We take a vegetable oil or an olive oil, we add hydrogen to it, and turn it into something like this, like margarine, for example. Margarine is hydrogenated vegetable oil, right? So it used to be thought, like when I was a kid growing up, we would eat dinner at the table every night together. My mom would cook, and we would all sit together at the dinner table. And every night, she would put margarine on the table, because margarine was better for you. And then about the time I was 15, my mom started putting butter on the table, because butter was better for you. And so it went from thinking, oh yeah, if we take olive oil and add hydrogen to it, that's bound to be better for you, because it started out better for you. In reality, we know that it's not any better. When you hydrogenate vegetable oil, you're turning it into this, and your body doesn't know the difference. In fact, it's just made in a lab. So now they say, avoid hydrogenated vegetable oils. Stick with butter. You can find it naturally in the environment. So it's not good to get a lot of saturated fat anyway, right? So hydrogenation is just adding hydrogen to the unsaturated fat, turning it into a solid. A lot of restaurants have eliminated trans fats and hydrogenated vegetable oils from their foods. So like I know in New York, the whole state of New York has banned trans fats from restaurants. So a restaurant cannot use trans fats. So that means like McDonald's, they cannot cook with trans fats anymore. Does that mean McDonald's is now healthy for you? No, it doesn't. It still is loaded with saturated fat. It's just not trans fat, right? It's just not hydrogenated vegetable oil. They're still using saturated fats though. In terms of where we use lipids in the body, so one place we use them is, remember we have those 4 lipid-soluble vitamins, A, D, E, and K. Remember, in order to absorb these, you have to have fat. So so they help with vitamin absorption. A lot of your liver cells will use lipids as their fuel source, and even skeletal muscles can use lipids as a fuel source. We know lipids are used in the myelin sheath surrounding your neurons. Lipids make up your adipose tissue, and fat tissue, we have it for a reason. Even really skinny people have fat tissue. It is there to protect your organs, it insulates your organs, it provides a cushion. It also can surround really active organs so that they have a fuel source right next to them. Okay, like your kidneys are surrounded with a layer of fat as a fuel source. Prostaglandins are lipids. These help with smooth muscle contraction. They also help with controlling your blood pressure. And then we know cholesterol is a lipid. And I already mentioned to you it is found in our plasma membrane, and it helps to stabilize that membrane. So there's a lot of uses of lipids in the body. In terms of how much we need about 30% or less of our total caloric intake being composed of fats throughout the day. And in fact, it should be mostly unsaturated fats, the good kind, the olive oils. In terms of saturated fat, it should be less than 10% saturated fat. The meats that have the most saturated fat are going to be red meat and organ meat. White meats, lean meats like chicken and turkey, those have a lot less saturated fat in them. They are better for you. Okay? Typical American diet, we're over. We consume about 40% of our total calories from fat. I know I've mentioned this one before when we talked about the heart, atherosclerosis, right? It's the hardening of your arteries. Remember we talked about how the aorta is really elastic. It's a really elastic artery so that it can expand and recoil. If it gets hard and it can't expand and recoil when the heart moves blood into it, then your blood pressure goes up. So when people have atherosclerosis and they have this hardening of the arteries, usually their blood pressure is elevated as well. And it used to be thought that this was just a disease we found in people who were a little older, who had, poor exercise habits, poor eating habits. But we see it in young kids because the diet today is a lot worse than it was when we were little. Our lifestyle has changed a lot, even from when I was growing up. I just told you we would sit down at the dinner table every night together. No exceptions. Nobody in our family, I didn't, or my brother, we didn't have sports practice after school. That was on the weekends, so we always had our nights together. And now, and if my brother told my mom he wanted to play baseball every night of the week, she would have said, no, we're not doing that. I'm busy. I have things to do. I'm not taking you to ball practice every night of the week. Now kids are going to sports practices and they're doing 6 nights a week of practice, and parents aren't getting home until 10 o'clock with their kids. And so it's a lot, you can't sit at the table together anymore. People are running through Chick-fil-A and they're running through McDonald's, and fast food is just a thing that we do now. And it's cheap. So a lot of people can't afford whole, fresh food. It's really expensive to get good quality food. So it's cheap and it's easy and it's convenient. And so now we see this a lot more in young people. We see issues with atherosclerosis. And junk food. Junk food has a lot of saturated fat in it as well. Now sometimes, you can buy stuff that has no fat, or it has fat substitutes in it. So a lot of times, if you're going to buy cookies that are fat-free, they have to do something to give that cookie the same mouth feel. So I know this sounds weird, but fat gives food a certain texture to it, and so we like that texture. If you take it out, it tastes like cardboard. And so things that they do as a fat substitute is sometimes they'll beat air into food. Other things that they might do when they remove the fat is they might add starches and gums. Anything that your body can't metabolize. If you can't metabolize it and break it down, you can't absorb it, and it does not count as calories, right? If you're not absorbing it and it's coming out the other end, we don't worry about it. Milk whey protein, and then there's something called Olustra or Olean. This is basically a cottonseed oil that they can use. Your body cannot absorb this, so it still gives food a certain lipid or fatty texture, but you don't absorb it, so it doesn't count as calories. If they aren't metabolized, they don't have any calories in them. Now the disadvantages of all of these, one is it cannot withstand the high heat of cooking. So I went home a little while ago, and I was cooking dinner for my parents, and my mom, all she had was like a tub of fake butter. I don't know what, like it was, I don't know what it was. I thought it was butter. And then I put it in a pan, and I was starting to cook, and I look at this butter, and the butter didn't melt like normal butter. It like turned into like a yellow glob of something, and then it looked like water around it. It was really weird. You can't put, I can't believe it's not butter in a pan and heat it up. You can't add it to cookies and bake them from scratch. It doesn't withstand the heat of cooking. So a lot of these things, you can't cook with them. And they taste different. They do. A lot of these will also cause gas and diarrhea, like Olestra and Alene. So my dad used to work for Procter & Gamble. Procter & Gamble, he was an engineer for Procter & Gamble, and he worked in the Pringles plant. And Pringles are made by Procter & Gamble, and when they, probably back in like the 90s, they came out with this Pringles with Alene or Olestra. And there's a little star on it, and it said, these are fat-free, but don't consume more than one serving because it may cause gas and diarrhea. And boy, when that stuff first came out, if you ate too many Pringles, you better have a seatbelt on your toilet because it was not going to be pretty. So a lot of times they'll give you that information if that's on a bag of snack food that has that in there. And then we know, obviously you got to have fat. You got to have it so you can absorb your fat-soluble vitamins. And then our last macromolecule I'll mention are proteins. We break proteins down into amino acids. And amino acids in our body, we use them to build up new proteins. You got to think about all the proteins we have in the body. We have a lot of proteins. They're used for a lot of different things. Enzymes are proteins. Hormones are proteins. Hemoglobin's a protein. Insulin is a protein. There are so many proteins in the body. So when you consume a protein, your body really breaks it into amino acids. You absorb it into your bloodstream so that you can build up new proteins that you need. Any amino acid that the body cannot make on its own is called an essential amino acid, meaning it is essential in your diet. You have to get it in your diet. Now, there's two kinds of proteins. A complete protein has large amounts of all these essential amino acids. So these are mostly going to be animal products. So meat, eggs, fish, poultry, cheese, all of these things are complete proteins. They have all of these essential amino acids in them. Incomplete proteins are mostly going to be coming from plants. So they lack one or more essential amino acid. So, you can see here things like nuts and seeds and legumes and vegetables. These are not considered complete proteins. This is why if somebody is a vegetarian and they're not consuming any meat products, any animal products, so if somebody's a vegetarian or a vegan, it is really important that they eat a very wide variety of foods. Eat a lot of different vegetables so that they can make sure they're getting all of their amino acids. This is just an example of that. So this is showing you, here are the amino acids, the essential amino acids. It's showing you you would need to get most of these, you would need to have corn and some kind of bean or legume, right, to get just this many, right? So you can pick up more by having a varied diet. So I mentioned, our body, when we eat a protein, we break it into amino acids so we can build up a protein we need. So we use proteins as structural material. Keratin, which we find in the skin and the hair and the nails, is a protein. Collagen and elastin, these are also proteins. And even muscle proteins like actin and myosin. We use them as functional molecules like enzymes and hormones. Those are proteins. And then, if we need to, we can use them for energy. But usually, they're the last thing we'll use for energy. So if you have no carbs, if you have no lipids, the last thing you'll use are proteins. But your body is not usually going to burn amino acids for energy. It needs those to make things. So there is this sort of all or none rule when your body is making a protein. That means that you have to have all the amino acids needed to make that protein. If you are missing one, you don't make the protein. It's all or none rule. Okay, so if you're missing one, you can't make it. Like I mentioned, we'll only use proteins if you don't have enough carbs or fat available. That's the only time you'll use proteins as fuel. So your body uses carbs for fuel, lipids for fuel, and then finally proteins for fuel. Typically, you're only using proteins if you're starving. So we do have what's called a nitrogen balance, and this is typically the rate of protein synthesis equals the rate of breakdown and loss. So you are making proteins at the same rate that you are breaking them down or losing them. Anytime you have a positive nitrogen balance, that means that you are making proteins faster than you're breaking them down. So usually you are building something up. So this is really common in kids because they're growing. They usually have a positive nitrogen balance. They're constantly getting bigger, so they need to be making them faster than they're breaking them down. Pregnant women, they're growing a whole new human being, right? So they have a positive nitrogen balance. And then tissue repair. What if you've broken a bone? You're going to have a positive nitrogen balance. You're building proteins faster than you're breaking them down. A negative nitrogen balance is the opposite. It means that you are breaking proteins down faster than you're building them up. So stress causes a negative nitrogen balance. Burns, infections, if you're injured, or if you're not eating well, if you're starving, all of these things would cause you to have a negative nitrogen balance. You're breaking them down faster than you're building them up. And in terms of proteins, I told you that they can be hormones, right? So some amino acids used as hormones are anabolic hormones. Anabolic hormones are things like the growth hormone and sex hormones. These cause you to produce more proteins and cause you to grow. Other proteins can be used as adrenoglucocorticoids. These get released during stress. So these are some hormones that cause you to break down protein, and you convert amino acids into glucose so that you can use them to produce energy. So that's what happens during times of stress. Now, in terms of dietary requirements, I can't give you a percentage because it varies. It varies based on your sex, your age. There's a lot of things that make a difference. Your metabolic rate, people who are really active and have a high metabolism, they need more protein than someone who is more sedentary. Again, we only use proteins to make energy if we do not have enough carbs or lipids. There are lots of children who have protein deficiencies, but not usually in the United States. We have very good social programs that make sure kids get fed. We have school lunch programs so that if kids are not eating, they're not getting enough food at home when they go to school, we know that they get a nice hot meal. I volunteer for an organization called Backpack Buddies. We go once a month and we pack food into bags, and we do thousands of bags each month. Teachers identify kids who are probably not getting food at home, and then the teacher will secretly put that bag in that kid's backpack on Friday. So that child, over the weekend, they've got something to eat in the backpack, right? So we have a lot of good social programs that make sure that kids don't go hungry, but that's not the same case in other countries. So, you can see, this child, that limbs are so tiny, that is a definite indication of a protein deficiency. In the United States, usually, we consume a lot of protein, usually 2 times the amount of protein that we need. Problem is, when you consume more protein than you need, your body is going to store that for later on. So you actually store it as fat. You can use it for energy later. So those are our macromolecules that I wanted to mention. So carbs, lipids, and proteins. These are all the same macromolecules you probably talked about in general biology when you did that one. I also want to mention a little bit about vitamins. Vitamins really just help your body use nutrients. That's their main role. And most vitamins act as coenzymes. A coenzyme is just something that helps to speed up a reaction. It just helps the reaction go through. Most vitamins aren't made in the body, so they have to be taken in with food. The exception to that I have listed here are things like vitamin D. Your skin makes vitamin D. It needs sun in order to make vitamin D. Some B and K vitamins can be produced by bacteria in the large intestine. And then beta-carotene is one that we find in carrots. This can get converted to vitamin A in our body. Usually not one food group contains all your vitamins, so you gotta have a balanced diet. You've got to be eating, vegetables and fruit and grains and proteins. Now, our vitamins, we've already talked about, we classify them as fat soluble. We have 4 of those, A, D, E, and K. All the rest are water soluble. Water soluble ones, these get pulled out of your food and they're absorbed in the GI tract. They're absorbed in the small intestine with water, but they're not stored in the body. Any that's not used within about an hour or 2 is going to get pulled out by the kidneys and excreted in your urine. So mega doses of water-soluble vitamins, not an issue. When I first started here, we used to have health fairs. I don't think we have those anymore. The Wellness Center would do health fairs, and so Manna Grocery was here, and they were giving out vitamin samples. And I took one when I had lunch. I thought, well, I'll just try this. I'll do it at lunch. And for the rest of the day, my urine was like the color of her coat. It was like sort of a weird yellowy, greeny, very bright, really strong smell. And I was like, oh my gosh. And I went back to my office and I pulled a little packet out of the trash, and it had like 2,000% of my daily recommended value of all these water-soluble vitamins. I made sure that the fat-soluble vitamins were still low, but those water-soluble vitamins, the amount was so high. That doesn't cause a problem, you urinate it out, but don't pay extra for vitamins that have mega doses in them. It's not going to help you. Fat-soluble vitamins, these are stored in your body. So they get absorbed with fat from your food, and then you store them in the fat in your body. So they can be toxic at high levels. I mentioned this on Tuesday. 4,000 Americans every year are treated for vitamin toxicity poisoning. This is a thing. Because these vitamins get pulled out with fat, they get absorbed along with fat, anything that interferes with fat absorption is going to interfere with the uptake of these vitamins. So if somebody has gallstones and they're not releasing enough bile, that's going to cause issues. They're not going to be able to absorb that fat and fat-soluble vitamins. I'll also mention antioxidants. These are types of vitamins that are helpful at removing free radicals. So free radicals are things that get generated during normal metabolism, so during normal reactions. So some vitamins like C, E, A, and selenium, these are considered antioxidants. Around now, they start having those ocean spray cranberry commercials where the guys are in the cranberry bog, and they talk about how cranberries are really good. They're antioxidants. Pomegranates are antioxidants, or they have antioxidants in them, and that is true. But vitamin C helps with that. Other things are things like broccoli and cauliflower and Brussels sprouts. Some of the major minerals that we get in our food, minerals, basically, we need these in moderate amounts if it's a major mineral, and those are listed up here. So these are going to be things like calcium. We got to have calcium. We've got to have, and we need calcium for everything. Right? If we think back to muscle physiology, we need calcium. Neurophysiology, we need calcium. We need it for every physiological function. So this is a major mineral. Phosphorus, potassium, sodium. Think about these. When we did muscle phys, the ions that we talked about were calcium, sodium, and potassium. Right? These are major minerals that are used in so many functions in your body. So we have to have these in moderate amounts in our food. Trace minerals, we need them in small amounts. And these just help to work with nutrients to make sure your body's functioning properly. And again, you usually rarely have toxic overload of minerals. Some examples, calcium, phosphorus, manganese, these all help to harden your bone. Iron, we got to have iron because this is what oxygen binds to in hemoglobin. Iodine, we need that in our thyroid, right? This helps our thyroid produce thyroid hormone. Sodium and chloride, these are major electrolytes in the blood. They help with physiological processes. So mineral-rich foods are basically fruits and vegetables and legumes and meats and milks.